All right, guys, so we're going to go ahead and do some practice problems over speed, distance, and time. Something helpful that you guys should start practicing is going ahead and writing out these equations. I will make sure to give you guys basic equations, but I'm not going to give you them all. I will give you speed, but then you're going to have to be able to reorganize these equations in order to solve for distance and time. I wanted to show you guys an easy way that I do that. If we know that speed equals distance over time, we can solve for distance and time because they're all three the same variables. The way I remember it is this. We have speed, and we know that it equals distance over time, okay? This pyramid triangle structure is going to help us remember how to rearrange those equations for those of us who are still struggling with a little bit of algebra. Speed multiplied by time gives us distance. So speed times time gives us distance. Distance divided by time gives us speed. And distance divided by speed gives us time. This will really help you throughout the course because a lot of our equations only have three variables, and you're going to have to learn how to reorder those. Remember that anytime you have division, something's on top of something else. There's a fraction. Anytime you're multiplying, something's next to something else. So that's how you can easily remember these formulas. Now, what we're going to do is we are going to have to take a little bit of time at the beginning to go ahead and identify what it's asking and what variables is given, okay? So I have traveled 100 yards in 10 minutes. What is my speed? So we're going to be looking for speed right here. And we've traveled 100 yards. 100 yards is going to be our distance, and 10 minutes is our time. We're looking for speed. So the way we're going to solve that is we know we need to use the speed equation. And we know that speed is equal to distance over time. So all we have to do is put 100 yards over 10 minutes. Now, there are going to be times in this course where I'm going to ask you to use very specific units, and you're going to have to use your knowledge from Unit 1 in conversions to simplify and convert units from something that's given to something that I want. In this case, because I did not ask you to do that, you just need to make sure your units are consistent. So make sure that you're aware of that as that's happening. We're going to have speed equals yards over minutes. So 100 divided by 10 gives us 10. And remember, guys, a lot of times we use miles per hour. Miles is a form of distance. Hours is a form of time. So it is perfectly fine to put yards per or yards slash minutes, okay? So you could do that, or you could put yards per minute, okay? Now, the second one, we've got Mackay, and he ran 12 miles per hour. Miles per hour should sound familiar. That's a speed for 2.5 hours. Hours is time. And I'm asking you, how far did he go? So I'm saying, what's the distance? So we know that distance is equal to speed times time. So distance is equal to speed times time. So all we have to do is we have to put 12 miles per hour. So distance is equal to 12 miles per hour times 2.5 hours. And then what we are going to get, 12 times 2.5 is 30. How do I get the units? We've got miles per hour and hours. This is the same thing as saying miles per hour times hours. Whenever we have something on bottom and we're multiplying it by something that's over 1, these are going to cancel out. And that's how we're left with just miles. And that's how we're left with distance. You guys are going to have to be really good about using the correct units, because if you don't give me the correct units, it's not going to be the correct answer. So 30 miles. That makes sense. If you gave me miles per hour, that wouldn't make sense. We don't use that distance unit. Number 3, Obama traveled 450 miles. So that's going to be our distance at 50 miles an hour. So that's going to be our speed. How long did his trip take? So what are we looking for? We're looking for time, okay? And we know that time is equal to distance over speed. So time is equal to distance over speed. So all we're going to do is we're going to put 450 miles over 50 miles per hour. Now, what are our units of time that we have? We've got minutes, seconds, hours, days, years, etc. I want you guys to look at this again. Miles is over miles, so that's going to cancel out. So what we're going to be left with is hours. So our units are going to be in hours, which makes sense. That's how long a trip could take. 450 divided by 50, type that into your calculator, you will get 9 hours. Now, number 4, a rhino can run at 20 meters per second. Meters per second. What does that sound like? Sounds like miles per hour. So that's going to be the equivalent to speed, and for 30 seconds. So that's time. We don't know how quick that is because we don't use meters, and we typically don't measure things in seconds as far as speed. So I want you to tell me, how far is the rhino able to run? So what is the distance? We know that distance is equal to speed times time. So distance is equal to speed times time. All we do is we say distance is equal speed. We know it's 20 meters per second times 30 seconds. So 20 times 30 gives us 600. Now what are the units? We're looking for distance. First of all, what is the distance that is in this at all? Meters. And then we've got seconds and seconds. Remember, seconds is on bottom and on top, so it's going to cross out, and we're going to be left with meters. And you guys can either use the abbreviation M, or you can write that out, okay? Number 5, you jog 20 minutes, so that's time, and travel 2 miles, which is distance. How fast are you going? So I want to know what the speed is. Speed is equal to distance over time. So speed is equal to distance over time. We have 2 miles, so 2 miles, speed equals 2 miles over 20 minutes. Now, if you wanted to convert this from minutes to hours, you are more than welcome to. However, I'm not requiring you to do that. I will always put that in the directions. So 2 divided by 20 gives us 0.1. Can these cancel out? Nope. So it's going to remain miles per minute. Mr. Stranges rolls down a 500-foot hill. Well, feet, that's a measure of distance. At 7 feet per second. Anytime it's distance over time, it's going to be speed. So speed, how long did it take her, oops, he's not going to be happy about that, him, to get to the bottom? So we're looking for time. So we know that time is equal to distance over speed. Distance over speed. So we're going to put 500 feet over 7 feet per second. So the first thing we're going to do is we're going to do 500 divided by 7, and we get 71.43. Our feet are going to cancel out, and we're going to be left with seconds. So 71.43 seconds. Last one on this page, a jet plane can cover 750 kilometers. Kilometers, meters, so that's a distance, in 15 minutes, which is a time. What is the speed of the jet? We know that speed is equal to distance over time. So we take the distance, which is 750 kilometers, divided by 15 minutes. So what we will do then, 750 divided by 15, you're going to get 50. Can kilometers and minutes cancel out? Nope, we've got distance and time. You can't cancel out two different units. So it would be 50 kilometers per minute. All right, let's go ahead and flip to the back. Same deal. What I would do first is anytime you're going to do this, remember, we know that speed equals distance over time. So distance divided by time equals speed. Speed times time equals distance. And distance divided by speed gives us time. Okay? So there is a unicorn that pranced 10,000 yards. Yards, that's going to be a distance, in 1 day. What does a day represent? Time. So what is its speed? We know that speed is equal to distance over time. So what you can do is just tell me 10,000 yards over 1 day. 10,000 divided by 1 gives us 10,000 yards per day. Some of you guys might think that's a little weird, okay? So this is the other way you could do this. Let's say we wanted to convert it. We know that 1 day is equal to 24 hours, okay? So we could theoretically say speed is equal to distance over time. So our distance would stay the same, 10,000 yards over, instead of days, we'll put hours. How many hours is in a day? We know 24 hours. 10,000 divided by 24 gives us 416.67 yards divided by hour. So all that is yards per hour. So the last one I'm going to do for you is number 9, and then I'll let you do number 10 and 11 on your own, but I will give you the answers for those. Number 9, Luke Jackson runs from his house to the gas station for Mountain Dew for his all-night gaming marathon in 5 minutes. 5 minutes represents time. The gas station is 2,000 meters away. That's going to be distance. What was Luke's speed and velocity? This is where I'm going to introduce velocity a little bit. I'm not going to go over it right now because that's in actually section, the end of section 1 of this module. So we're just going to solve for speed right now. What was Luke's speed? We know that speed is equal to distance over time. So we know the distance he traveled was 2,000 meters. We know the time he traveled was 5 minutes. So 2,000 divided by 5 is 400. Meters and minutes can't cancel out, so it is meters per minute. Okay? Now, number 10's correct answer, it's asking you how far is she going to go. So I'm asking you, what is her distance? Her distance would be 15 yards is the correct answer. Number 11 is asking how long has she been looking, so what is the time? And the correct answer is 4 hours. If you're still struggling on those, make sure you come and see me, and I'm happy to go over those in person during my office hours. Thanks.